Hey everyone, today I'm going to explain to you the design and function of the automotive light bulb, headlights, steel beam, halogen, and HID headlights. Then I'm going to describe the design of single and dual filament light bulbs, describe steel beam design, and describe the operation of halogen and high intensity discharge headlights. Technicians must understand basic light circuits to be able to maintain, diagnose, and service these systems. When the operation of the circuit is understood, diagnosing becomes much easier and faster. An automotive light bulb usually contains one or two filaments. In a single filament bulb, the terminal is connected to one side of the filament, and the opposite end of the filament is usually connected to the bulb case. Voltage is supplied to the bulb terminal, and current flows through the filament to the bulb case. The circuit is completed from the bulb case through the vehicle ground back to the battery. The indexing pins on the sides of the case retain the bulb in the socket. Many automotive bulbs have two filaments and two terminals that supply voltage to the filaments. These dual filament bulbs serve two purposes, such as stoplights and tail lights. The indexing pins position the bulb terminals properly in the socket. A variety of different bulbs are used in a typical vehicle. When current flows through a bulb filament, it becomes very hot. The electrical energy in the filament is changed to heat energy. And this action is so intense that the filament glows and gives off light. This process of changing electrical energy to heat energy that produces light is called incandescence. The filament is surrounded by a vacuum that prevents overheating and destruction of the filament. When a bulb is manufactured, a vacuum is sealed inside the glass envelope surrounding the bulb. Seal beam headlights may be round or rectangular shaped. Seal beam headlights have a parabolic reflector sprayed with vaporized aluminum in the rear of the seal beam. This reflector is fused to a glass lens in the manufacturing process. All the oxygen is removed from the seal beam and then it is filled with argon gas. Argon gas is an inert gas. If oxygen were allowed to remain in the seal beam, the filament would become oxidized and burn out quickly. Seal beams may contain one or two filaments. If the seal beam operates on both high and low beam, it has two filaments and three terminals. Some seal beams that operate only on high beam contain a single filament and two terminals. The light from the filament in a seal beam is reflected from the reflector through concave prisms in the lens. The prisms in the lens direct the light beam downward in a flat, horizontal pattern. The filaments are precisely located in the reflector to properly direct the light. If a seal beam has two filaments, the lower filament is for high beam and the upper filament is for low beam. Many newer vehicles have halogen headlights. This type of headlight contains a small bulb filled with iodine vapor. The bulb has a glass or plastic envelope surrounding a tungsten filament. The bulb is installed in a sealed glass housing. Because the bulb is in halogen headlight is self-contained, a cracked lens does not prevent headlight operation. However, a cracked lens should be replaced because it results in poor light quality. Halogen is a term for a group of chemically related non-metallic elements, including chlorine, fluorine, and iodine. The tungsten filament can withstand higher temperature and burn brighter because of the halogen added to the bulb. Halogen highlights produce approximately 25% more light compared to seal beam headlights. Many vehicles are presently equipped with composite headlights and replaceable halogen bulbs. The composite headlights allow the vehicle manufacturers to design the headlights in various shapes to conform to more aerodynamic body styling. For example, some composite headlights wrap around the front corner of the vehicle. When replacing a halogen or HID bulb, avoid touching the glass with your finger. The oil will eventually cause the bulb to crack when it's used and shorten its service life. In recent years, some vehicles have been equipped with high intensity discharge or HID headlights. In HID headlights, the light is produced from high voltage arcs across an air gap between two electrodes. An inert gas, for example, helium, nitrogen, or argon gas, in the headlight amplifies the light provided by the high voltage arcing. Approximately 15,000 to 25,000 volts are required to initially force current across the air gap between the electrodes. Once this air gap is bridged with a stream of electrons, about 80 volts are required to maintain the current flow across the gap. A voltage booster and controller are required to provide this higher voltage. Compared to halogen headlights, the HID or the high intensity discharge lights provide approximately 3 times more light, draw less current, and last twice as long. The improved light output from the HID lights allows the lights to be smaller, and this makes it possible for the vehicle manufacturers to be more flexible in the front end body styling. That's it for today's topic. Thank you for watching.